A linear function is a function of the form f of x equals ax plus b, where a and b represent real numbers. And when we show this graphically, a represents the gradient of the function and b represents the y-axis intersect, which is sometimes called the vertical intercept. Now, what do you think would happen if we varied a? Well, let's have a look at a few examples. Now, because we're looking at the graphs of linear functions, that means we're going to be looking at straight lines. And to plot a straight line, we only need 2 points. However, we often choose 3 points, because the third point is a good check to make sure we haven't made a mistake. So let's have a look at f of x equals x plus 2. OK, first point I'll look at is f of 0. Now, f of 0 is 0 plus 2, which is simply 2. F of 1 is 1 plus 2, which gives us 3. And f of 2, 2 plus 2, which will give us 4. OK, for the next function, let's look at f of x equals 2x plus 2. F of x equals 2x plus 2. So we get f of 0 equals 2 times 0, which is 0, plus 2, which gives us 2. F of 1, which gives us 2 times 1, which is 2, plus 2, which gives us 4. And f of 2, which gives us 2 times 2, which is 4, plus 2, which gives us 6. There's no reason why a shouldn't be negative, so let's look at a few negative values. If we had f of x equals minus 2x plus 2, then we would have f of 0 equals minus 2 times 0, which is 0, plus 2, which gives us 2. F of 1, which gives us minus 2 times 1, which is minus 2, plus 2, which gives us 0. And f of 2, which gives us minus 2 times 2, which is minus 4, plus 2, which gives us minus 2. And finally, we'll look at f of x equals minus x plus 2. So we get f of 0 equals 0 plus 2, which is 2. F of 1, which equals minus 1 plus 2, which equals 1. And finally, f of 2, which is minus 2 plus 2, which equals 0. Now, what we're interested in doing is looking at the graphs of these functions. So if we have our axes drawn with f of x on the vertical scale and x on the horizontal axis, the first function we looked at was f of x equals x plus 2, which gave us points at 0, 2. Second point was at 1, 3. Our third point was at 2, 4. And when we join this up, we expect a straight line. We can label this f of x equals x plus 2. The second function we looked at was f of x equals 2x plus 2, which gave us the point 0, 2, which we've already marked. It gave us the point 1, 4. And it gave us the point 2, 6. We should be able to draw these up with a straight line. We can label this f of x equals 2x plus 2. The next function we looked at was f of x equals minus 2x plus 2. And once again, this gave us a point at 0, 2, a point at 1, 0, and a point at 2 and minus 2. And when we join these up, as before, we expect a straight line. We can label this f of x equals minus 2x plus 2. And the final function we looked at was f of x equals minus x plus 2. And this gave us a point at 0, 2 again, a point at 1, 1, and a point at 2, 0. And we can join those up to get a straight line. And this is f of x equals minus x plus 2. Now, first thing we notice about these graphs is that they all cross 2 on the f of x axis. That's because the b value is 2 in every single function, and b represents the y-axis intercept. What we were interested in is what happens as the value of a changes. Now, when a is positive, the line goes up, and the bigger the value of a, the faster the line goes up as x increases. And when a is negative, the line goes down. And the bigger the value of a in absolute terms, the faster the line goes down as x increases. Okay, so what happens as we vary b? Well, as always, a good place to start is by actually looking at a few examples. So let's consider the example f of x equals 2x plus 3. F of 0 here would be 2 times 0 plus 3, which is 0 plus 3, which is just 3. F of 1 is 2 times 1, which gives me 2, plus 3, which gives me 5. And f of 2 gives me 2 times 2, which is 4, plus 3, which gives me 7. Okay, next function I'll look at is f of x equals 2x plus 1. Okay, for this function, we get f of 0 is equal to 2 times 0, which is 0, plus 1, which gives me 1. F of 1 gives me 2 times 1, which is 2, plus 1, which gives me 3. And f of 2 gives me 2 times 2, which is 4, plus 1, which gives me 5. And the final function I want to look at is f of x equals 2x minus 3. So f of x equals 2x minus 3. So f of 0 is 2 times 0, which is 0, take away 3, which is minus 3. F of 1 is 2 times 1, which is 2, take away 3 gives me minus 1. And finally, f of 2, which is 2 times 2, which is 4, take away 3, which gives me 1. So what we're interested in doing is looking at the graphs of these functions. So as usual, we'll have our f of x on the vertical axis and x on the horizontal axis. So the first function we talked about was f of x equals 2x plus 3. And the points we had were 0 and 3, 1 and 5, and 2 and 7. We can join those up. With a straight line. Label that f of x equals 2x plus 3. The next function we looked at was f of x equals 2x plus 1. And the points we had there were 0 and 1, 1 and 3, 2 and 5. Once again, we can draw those, drawing those up with a ruler. And label that one f of x equals 2x plus 1. And the final function we looked at was f of x equals 2x minus 3. And the points we had were 0 and minus 3, 1 and minus 1, and 2 and 1. We can join those up as before with a ruler. We label this, we get f of x equals 2x minus 3. Okay, first thing we notice here is that all the graphs are parallel. In fact, they have the same gradient. And that's because, in each case, the value of a was 2. So all the graphs have a gradient of 2. And we also notice that as we varied b, when b was 3, the graph of the function went through 3 on the f of x axis. When b was 1, the graph of the function went through 1 on the f of x axis. And when b was minus 3, the graph of the function went through minus 3 on the f of x axis. Okay, so we know what happens when a and b are positive and when a and b are negative. What happens if a and b are 0? Well, let's think about what happens when a equals 0 first of all. So if a equals 0, we get a function of the form f of x equals a constant. So that could be, for example, f of x equals 2 or f of x equals minus 3. Just a couple of examples. And we can sketch what they might look like. The f of x axis here. Now x axis here. F of x equals 2. That means for whatever the value of x, the f of x value is always 2. So in fact, we just get a horizontal line which comes through 2 on the f of x axis. So f of x equals 2. And when f of x equals minus 3, we get a horizontal line that just comes through minus 3 on the f of x axis. So that's what happens when a equals 0. But what about when b equals 0? Well, let's have a look. For b equals 0, we get a function of the form f of x equals ax. And as we said at the beginning, a can be any real number. So, for example, we might have f of x equals 2x, or f of x equals minus 3x. Okay, and as we've already said, what happens when we use these values of a, f of x and x, if we're looking at f of x equals 2x, it's going to come through the origin because b equals 0, so it will cross f of x at 0. And it will have a gradient of 2, since a is 2. So as a sketch, this could represent f of x equals 2x. f of x equals minus 3x, once again, we'll go through the origin, because b equals 0, and it has a gradient of minus 3. Remember, the minus means the line is coming down, and the 3 means that it's going to be a bit steeper than it was before, so it might be like this. So f of x equals minus 3x. Okay, lastly, I want to look at functions which are not in the form f of x equals ax plus b. So, what would we do? So we want our functions in the form f of x equals ax plus b. And it's quite useful to think about now if we used y equals f of x, just for convenience. So suppose I had 4x minus 3y equals 2. First thing we want to do is make y the subject of this equation. So if I add 3y onto both sides, 4x equals 2 plus 3y. Now I want to get 3y by itself, so I need to take away 2 from both sides. So over here I get 4x, take away 2. On this side, if I take away 2, we just get left with 3y. And so finally, to make y the subject, I need to divide both sides by 3. So I get 4/3 of x minus 2/3 equals y. And as we said before, y equals f of x. So this means our function is actually f of x equals 4/3 x minus 2/3. So this function represents a straight line with a gradient of 4/3 and a y-axis intercept of minus 2/3. What about if we had 2x minus 8y, so plus 8y, minus 1 equals 0. Once again, we want to make y the subject of the equation. So a natural first step would be to add 1 to both sides. So 2x plus 8y equals 1. Next thing we want to do to get 8y by itself is to subtract 2x from both sides. If we subtract 2x from this side, we just get left with 8y. On this side, we get 1, take away 2x. And finally, we need to divide both sides by 8, since we just want y, and we've got 8y there. So divide both sides by 8, we get y equals 1/8 minus 2 over 8 times x. And obviously, we want our function in the form ax plus b, which means we would change around, just rearrange this right-hand side here to get y equals minus 2/8 of x plus 1/8. And we can simplify minus 2/8 to be minus 1/4. So we get minus 1/4 of x plus 1/8. And as we said before, y equals f of x. So here we have it. Our function is f of x equals minus 1/4 x plus 1/8. And graphically, this is represented by a straight line with a gradient of minus 1/4 and a y-axis intercept of 1/8. What about if we had this example? Y equals 13x minus 8 all divided by 5. Now, although y is already the subject of the formula, it's not quite in the required form, and that's because of this divide by 5. But we can just rewrite the right-hand side as y equals 13x divided by 5 minus 8 divided by 5. And since y is f of x, we can write this as f of x equals 13 over 5x minus 8 over 5. So this function is represented graphically by a straight line with a gradient of 13 over 5 and a y-axis intercept of minus 8/5.